Hey, AP, let's look at some Qsp versus Ksp. So there's a couple of nice nuances here. And so remember Ksp, solubility product constant, is that value, that number that tells you how much at equilibrium, how much of our solid actually dissolves in the solution. The bigger the Ksp, the more soluble our substance is. Our Qsp then, as we think about what that means in terms of where we are, our Q is the reaction quotient. It's a snapshot at any given point in time that lets us then compare to the K. It's just a directionality. As a reminder, if Q is equal to K, then that means we're at equilibrium. That means we've dissolved as much into the solution as we're going to get. Our solution is said to be saturated. If Q is less than our Ksp, well, that means we're not quite there yet. We're undersaturated. We could dissolve more particles if we wanted to. And if Q is greater than Ksp, we're oversaturated. We tried to put too much in. And so as a result, some of these particles are going to precipitate back out. And so knowing this, keeping this in mind, we can actually start to look at some example problems and say, okay, if I mix these two things, am I going to get a precipitate? A couple of nuances, a couple of things to consider when we look at these kinds of questions. Is first of all, what's our precipitate going to be? We know something's going to be a solid. We've been given a Ksp. We got to figure out what that's for. So we got a common lab method for preparing a precipitate is to mix solutions of the component ions. Does a precipitate form when we add some calcium nitrate to some sodium fluoride? Okay, I'm going to disappear here real quick so I can do a little scribble. So start with your ions. What's floating around in there? What's in the beaker? We got some calcium nitrate, CaNO3. We're adding to that some sodium fluoride. If we're just thinking about it in terms of our double displacement, what are we going to make? Well, sodium fluoride, right? So we'd end up with our sodium nitrate plus our calcium fluoride. Double check my balance here. I think I need 2 here and 2 here. Not that it's going to matter real much. Okay, cool. So here's what we got. We got 2 aqueous solutions. We're making sodium nitrate and calcium fluoride. Of these two products, which is always going to be soluble? If we're thinking about our solubility, we know that sodium and nitrate's always soluble. So this is our aqueous thing. So if we're looking for a Ksp, it must be this other particle. It's going to be our calcium fluoride. So, okay, we got a Ksp. What's a Ksp describe? It describes how well does this solid that formed in our first reaction, how well does this dissolve into solution? So this is kind of the first nuanced piece. Thinking about, okay, what things did I put in here? Which one of these is going to be our solid that would then potentially be a viable Ksp expression? Once we've got that, now we can look and see what are we actually adding together? What is it that we're mixing? Well, it looks like we've got 2 different volumes all being mixed together, which means our volumes are going to change. As a result, the concentrations are going to change. We know we use concentrations for Ksp, which means we're going to need to do a little work here to get to moles. Remember that moles equals molarity times our liters, which means I think we're dealing, if we're thinking about our calcium nitrate will be our 0.1 times 0.3, which is going to give us for our calcium concentration, right? Because this is where the calcium's coming from. It comes from the calcium nitrate. It's going to have a mole value of, what do we got? 0.0300 moles. When I multiply these 2 numbers together, I would do the same for my fluoride ions, right? Here's where my F's coming from. I'll multiply those together to get our moles. We would have 0.2 times 0.06. When we multiply those together, we get 0.012 mole. So I'm going to clean this up just a little bit. Give me 1 second. I'm going to just spread these out a little bit so we got more room. What's our 2F minus in aqueous solution? Oh, but remember, for Ksp, in order for us to use kind of our ice table or use our Ksp value, we need molarity. Oh, okay. Well, that's okay. Because we've added these 2 solutions together, right? So we would divide both these moles by our new volume, which is a 0.1 Our new volume is going to be 0.1 plus our 0.2. Our new volume is 0.300 molar. Oh, no, not molar, liters. 0.300 liters. This is going to give us the molarity of these two solutions. When we divide those, we end up with a molarity for both. Let me grab a different color here. Molarity for both, we've got for our calcium ions, we've got 0.10 molar floating around there. For our fluoride ions, we got 0.040 molar floating around. Here's our second nuance piece. The question is, do we need to do anything with this 2 yet? All we've done thus far is say, okay, what is actually floating around when I put these two things together? Well, here's how much calcium. The calcium came from our calcium nitrate. Sorry, it's getting a little garbled up here. We've got our calcium nitrate. It was a 1-to-1. So we just solved using our molarities. We got our fluoride coming from our sodium fluoride. That's also going to be for our F- from the sodiums. It's a 1-to-1. For every 1 sodium fluoride that dissociates, we get 1 fluoride ion. So here are the concentrations floating around right now, right when we pour these 2 beakers together. Now the question is, will it precipitate? Here's the Ksp. Here's the Ksp. Here's our concentrations right at a given point in time. So I think we would use these for a Q. We're going to plug these in for a Q. We're going to solve for a Q, but good news, it's the same setup. Q for this reaction is going to equal our calcium 2 plus times our fluoride concentration quantity squared. That's the expression. Now we can take our 2 numbers and just plug them in. We know right when we mix 2 beakers together that the calcium concentration is going to be 0.10. And right when we mix the 2 beakers together, we know the concentration of the fluoride is going to be 0.40. According to our expression, we're going to square that to solve for the Q at this particular point in time when both of these things get mixed together. Well, when we solve for our Q, then we end up with 1.6 times 10 to the -4th. Yay, we got a number. Wait. How does that Q then compare to our K? Well, this Q is way bigger, right? 10 to the -4th is way bigger than what the Ksp is for this solution, which means we have oversaturated the solution. We are going to see a precipitate. I didn't spell that right. We would see a precipitate form in this reaction. Sorry. There's our final answer for this question. So the other nuance here is, when do we use that 2, right? And we'll talk more about this when I get back to see you guys. Sometimes we use it, sometimes we don't. We got to think about, where are these ions coming from when we're actually going about solving for our final reaction. Cool, got some sample problems for you to be working. We'll be taking questions when I see you again.